My name is Daniel Hammer, and I worked with Dr. William Grayling this summer researching the benefits of the Rust programming language for operating systems and concurrent programming. The problem is that most operating systems are programmed in a language known as C, which is very old and very insecure, but its speed keeps it very viable. Java is a newer language that's used often for concurrent programming that is much more stable, but it's very slow. Rust is a very new and young programming language that offers the speed of C and the stability and security of Java, all in one simple package. Many common security exploits exist in industry currently, and they're due to things that are very easy to replicate in languages such as C and Java, but are very hard, if not impossible, to replicate in Rust. So our research goals were to take the coursework from the CS370, or Operating Systems and Concurrent Programming course, at Western Carolina, and translate the coursework from C and Java into Rust. We then test the speed, security, and stability of these programs from the Java and C counterparts into Rust and see if there was any benefit. By the end, we wanted to survey students to see that if the programs were easier to understand and if they gained any concepts and skills that they could use to transfer over into industry. Our methodology was to take existing coursework from that class and translate it into Rust bit by bit. We see if we could not necessarily do a one-by-one, line-by-line comparison, but to write a Rust program that illustrates the same core concept and see if that Rust does it better. We would test to see if Rust is faster, more reliable, and more robust. As an example, many programs have to read in data files. As you can see, Rust can do this much quicker and much fewer lines of code and is much more readable than Java can. Our results were expected. Programs on average had fewer lines of code in Rust and faster runtimes. There were also fewer, if not any at all, security vulnerabilities in Rust compared to the Java and C programs. Even when we attempted to replicate these security vulnerabilities, we found a very hard time to do so. For concurrent programming specifically, our tests showed that Rust allowed for 16% more work to be executed at once than Java due to the way that Java manages concurrent tasks. Overall, we showed that Rust had proven to be a significant improvement over many of the old languages used in CS370. It was more faster, more efficient, and safer than Java and C. Students graduating from with experience in Rust will likely have better skill sets to introduce into industry, as now they're able to handle memory errors and security vulnerabilities that other programmers overlook.